The ALFA project is about border surveillance, and we are especially interested in the detection of low-flying objects such as helicopters, fixed-wing or drones. And we are also interested to know what are their intent. So basically to know if they might drop off something or where they might land. And one of the interesting applications is counter drug smuggling. We are now in Castellavella in order to detect, track and classify targets of opportunities, but also targets that we've been organizing, like a fixed wing, several drones and an helicopter. The difference between an helicopter and a drone, or an helicopter and a fixed wing, is quite obvious with an image, with a camera sensor. But what we want to do is to see those differences at much larger range, and for that we use a radar. And what we do with the radar is to process the radar signal that is backscattered by this target in order to determine what it is. One of the specificities of these flying targets is that they have moving parts, like the propellers of a drone or the blade of an helicopter, and they rotate at a different speed, they act slightly differently, and this kind of differences we can see in the radar signal. And with the smart processing we are able to know what a target actually is by looking at the radar signal. At GNR they already have a border system that detects surface targets like ships, and they're able to track them in order to know if there's some smuggling activity going on. What is new with the system we are building in ALFA is that we are not only looking at the surface, but we also can look at what is going on in the low-level airspace, and that means up to basically 300 meters above ground. Then we can detect, track and classify those low-flying targets like helicopters, drones or fixed-wing. I think that the systems that GNR now has would be possibly updated with some of this new system we are building now, because we have a complete surveillance of a certain area, not only on the surface but also a little bit higher in the sky. In order to build a good classifier, we need to be able to train and test it. And in order to do so, we need data. And that means we have been conducting measurement campaigns, and even these days we are again recording data in order to constantly improve our classifier. There's always something that might pop up we've never seen before, and we need to be aware of it. And that's why we are collecting huge amount of data to perform that job. A successful ending of this exercise in Portugal would be that we've integrated the system correctly, that everything is working from the sensor up to the man-machine interface. And another thing, of course, is that each sensor is delivering what it should. And one of the main things that the radar sensor is providing are the target tracks, but also it plays a big role in the classification. So if our classifier performs already well today, that means that we have had a successful week. That worried me in the ALFA project is the integration part. We are multiple companies with a different culture, different knowledge, and we have to integrate system at a given point in time. In order to prevent that integration will not work, we have been exercising well before this demonstration. We have been gathering already twice with all the equipment we had in order to test its integration. So now this part has been successfully achieved. The next thing that is, of course, most worrying if it's a sensor are not delivering what they should. So we are carefully watching at the moment what the classifier is doing. So far it's doing well, but we will have confirmation when we will have seen all the targets. We have 9 project partners within ALFA from all over Europe. This project will be mainly done in October, where we have a final demonstration.